Let me welcome you to the 45th lecture of NPTEL online certification course Drilling and Blasting Technology. This is our last tutorial on cost analysis of drilling and blasting. So, in this lecture we will carry out the cost analysis for blasting operations. So far we have already covered the drilling and blasting technology, the designing principles, results of blastings are also discussed, how to allocate number of machines, how to carry out the designing and how to calculate the yield for a drilling blasting operations are also discussed. In last few classes we have discussed the cost analysis, how to carry out the theoretical cost analysis and actual cost analysis for drilling and blasting operations, and we have already covered in last class the drill costing for surface bench blasting and drill costing for underground drift blasting is already covered, and in this class we will cover the how to calculate the blasting cost. So, to understand that, let us consider one problem. Say there is a surface mine where the blasting is carried out, bench height is 10 meter, drill hole dia is given 125 mm, burden is 3 meter, spacing is 4 meter, shaft drilling is 1 meter we have considered, and we are considering that we are using emulsion explosive of 1.2 gram per centimeter cube, that is the specific gravity of 1.2 we can consider, or maybe 1200 kg per meter cube is the density can be considered, and charge height in the hole, that is the 10 plus 1 11 meter hole, the charge will be provided of around 7 meter and 4 meter will be stemming. So, the production target is given 12 million meter cube, that means 12 into 10 to the power 6 meter cube, and we are having 250 round blasting will be carried out in that mine, and the explosive and accessories price list is given. Emulsion is 60 rupees per kilo. For detonating emulsion we need to have primer or booster in each hole, that is 500 gram per piece, and that piece price is 25 rupees. Electronic detonator price is also given, that is 1200 rupees, and nonel DTH price is also given. For 12 meter down the hole nonel price is 240 rupees, and TLD of 5 meter which is used trunk line delay, down the hole nonel and trunk line delay, that is trunk line delay is 100 rupees and 5 meter length, nonel 12 meter length 240 rupees. So, basically it is 20 rupees per meter is considered as the costing, and electric detonator, one detonator is required when we carry out nonel. So, to initiate the first TLD nonel in the surface we need to utilize this electric detonator. So, that is say price is rupees 10. So, we have to find out the blasting cost, powder factor, all these are there. Mainly actually our aim is to compare if the blasting is carried out with the electronic detonator where all these things are not required, then what is the pricing, and if we are not using electronic detonator, but using nonel electric detonator nonel TLD, then what is the pricing, what is the difference between these two pricing will be compared in this tutorial. So, for this let us first understand the requirement of our blasting. So, our yearly target is given 12 into 10 to the power 6 meter cube, and blast round numbers is given to 50 round. So, what we have obtained from blasting of one hole, see if we are carrying out blasting of one hole, this portion of rock will be blasted only, So, that is why the material yield is equal to burden into spacing into bench height. So, in this case it is 3 into 4 into 10. So, 120 meter cube material will be obtained from blasting of single hole. So, as 120 meter cube material is obtained from blasting a single hole, the number of holes we need to blast per year is 12 into 10 to the power 6 divided by 120, that means 10 to the power 5 number of holes to be blasted per year. Now, in one round obviously we have 250 rounds of blast. So, in one round we will have to blast 400 holes. Okay. So, this is basically calculated here, drill holes to be blasted in a year, and this is the holes per round. So, this is a very big blasting where 400 number of holes will be blasted. So, let us look what could be the possible blast design. So, if consider this is our free face, you may have any type of pattern here. Okay. So, this I have given rectangular pattern, but you may have staggered pattern also. So, by this way you can have your blasting pattern, and there are, if you are looking at the whole cross section, this is the burden 4 meter, sorry 3 meter, this is the bench height 10 meter, this is the charge length 7 meter, 4 meter stemming, 1 meter sub drilling. So, this is basically 4 meter, this is 3 meter, 3 meter, 4 meter. So, these are the burden and spacing given. So, we can have any combinations, we can have 5 rows of 80 holes, we can have 4 rows of 100 holes each row. Okay. So, but the every round we are basically carrying out blasting of 400 holes. So, that is the design we are considering. That is the design we are considering, and we have to carry out blasting here, and based on that we have to also consider the cost of blasting. Now, let us see what is the explosive requirement in one hole. We have seen that we are placing explosive as it is bulk emulsion. So, it is emulsion is taking the full diameter of the hole. Okay. So, the linear charge concentration is pi d square by 4 L rho. So, pi d square rho of explosive is basically the linear charge concentration, and if the length of charge column is L, then this is the quantity of charge. Okay. So, considering this, d is 125 mm. So, this is d square by 4, and L is the length, that is 7 meter, and rho is given 1.2 gram per centimeter cube, 2 into 1000 kg. Sorry, into 1000 now this is kg and this is 1 by 100 cube. So, this is meter cube. So, this is 1.2 into 100 into 100 into 100 divided by 1000. So, this is coming 1200 kg per meter cube. So, we are utilizing this is kg per meter cube. So, considering this, we have found in 7 meter hole 103 kg of explosives are placed. So, that means each hole is having 103 kg of explosive per hole. Okay. So, obviously, in 400 holes we need almost 40,000 kilos of explosives are required in every round of the blasts. Okay. So, that is the requirement. Now, let us go for cost analysis. So, as blasting has to be carried out, there must be one explosive van, though bulk truck is basically coming to load the emulsion explosive to the hole, and that truck price does not include, because the truck has to be owned by the explosive manufacturing companies, and the price they are charging in per kg of explosive, that is already included. The truck price, that bulk truck price is included in that price. So, that separately bulk truck price are not considered when the mining people are analyzing the capital cost, but one explosive van in which the detonator, the nonel, those accessories are basically taken, that must be there along with that exploder, etcetera. Those things are also has to be brought separately, not together, but separately, that has to bring there. So, for that magazine, that explosive van has to be kept. So, that considerations is made that the price is 2 million rupees, that is the 20 lakh rupees is the price of the van, almost equivalent to one truck it is there, and it is having 10 years of life, no scrap value. So, considering that in 10 years our production will be 12 into 10 to the power 6 meter cube. So, in 10 years our total production will be 12 into 10 into 10 to the power 6 meter cube. So, that cost of that van in rupees per meter cube is coming almost 0. So, you can consider the capital cost in this case is not very significant enough. So, that is shown in this case. Maintenance cost is also again based on the capital cost, that 20% of the capital cost, again it is almost close to 0. Then the operating cost is there, that is the power cost, that is the power consumption by the explosive van, though its capital cost is not very significant, but there is a little bit power consumption, that is fuel consumption is there. That fuel consumption, let us consider it is in each blast round it is consuming 30 liter of fuel. That means, the van is going to magazine, it is taking detonator etcetera from the magazine, coming back from the magazine. So, by this way it is consuming 30 liter of diesel. Diesel price is 100 rupees per liter. Considering it is consuming around 30 into 100, that is the rupees consumed, and the yield in one blast round is 120 meter cube in one hole. So, 400 holes. So, this is meter cube and this is number of holes. So, this is the yield from one blast round. So, that is the production. So, it is coming around 6 paisa per meter cube. So, this is the fuel price, that is the fuel consumed by running the diesel operated explosive van. Now, let us consider explosive prices. There is the 103 kgs of explosives are placed in the hole and the price is 60 rupees and in the hole 120 meter cube is yield. So, it is coming around 51 rupees 50 paisa is the coming 103 into 60 divided by 120. So, 51 rupees 50 paisa is the explosive cost. There is another cost which is missing here, that is the booster or primer. So, the price of the booster or primer is 25 rupees per piece, and we need to place in one hole. The charging system is like this. We have to place the primer here and the detonator, whether it is electronic detonator or non-L, will initiate that one and then the explosive has to be initiated by this booster. So, in one hole one booster is required. So, the booster price is coming 25 rupees, in one hole our yield is 120 meter cube. So, this is almost coming, around 25 paisa or so, okay, 0.25 rupees per meter cube. So, it is also not very significant, that is why we have not considered here, because the price is not very significant. So, that is why this costing, but this is also essentially required. One should not forget of finding out the calculation out of this. So, now let us consider. So, this is actually the explosive cost and booster cost we have found also. Booster cost is 25 rupees per meter cube is also coming, but electronic detonator we have found in one hole. We are using one electronic detonator. So, it is 1200 rupees. So, that is 10 rupees per meter cube is the direct cost coming to the in the costing for the use of electronic detonator only. Okay. Now, let us see how we will connect the electronic detonator, because if you are using electronic detonator, you need not to have to use any other thing except the logger. Logger is also provided on free basis to the electronic detonator provider, okay, manufacturer. So, that is why the electronic detonators are basically connected in the hole. This detonators are placed inside the booster, then the booster is connected with the explosives. So, that is why the connections are made like this way, and only the two wires coming out from the electronic detonator, which is connected with the power circuit. So, basically the electronic detonators, if you are looking at, consider this is the free phase. In that case, the electronic detonators are placed inside this. Only the positive and negative wires, that is coming two connecting wires. Actually, it is not positive, it is the communication cable, positive negative, it is not like that, it is communication cable which is being controlled by this logger. So, these two wires are basically connected with two communicating wires, and all the holes are having two wires like this. So, from one wire only the total connection is made, and we can carry out blasting, so that this portion will be blasted and the logger will remain safe. So, this electrical connecting wires are also consumed, but this price is included in the price of the detonator. That is why when the electronic detonator cost is considered, no other cost is considered, only the detonator cost is considered. So, that is why the detonator cost for each hole is considered as 1200 rupees, and that is the only cost considered in this case. So, by this way the connections are made. By this way the connections are made, and let us then calculate it for the manpower cost. We have already discussed in previous lecture also, manpower cost we considered based on the earning per man shift. Again we have considered the earning per man shift is 4000 rupees, and we have considered there are 5 person, 1 is blaster, 4 is blasting helper. In fact, drilling and blasting, drilling does not need many manpower because it is mostly mechanized, but blasting required a little bit more manpower because of two things. One is that all the drill holes, after placing the explosives, the stemming has to be carried out. So, this stemming operation is basically carried out using the drill cuttings or sand. So, placing the drill cuttings or sand inside this hole is little bit labor intensive, and that is why the more manpowers are required. Apart from that, those manpowers are utilized for blocking the access ways during the time of blasting, so that no one can enter into the blasting site. So, that is they also act as the security personnel when the blasting is basically carried out. So, that is the way basically the blasting is practiced. So, here you can see there are 5 persons required. This 5 person in one shift, their salary is 4000 rupees EMS. So, 5 into 4000 rupees is the one shift cost. So, in one round we consider that in one shift only one round blasting is carried out, because it is 400 holes, it takes significant time for that. So, for this we have considered one shift operation will be there. So, in one shift one hole our production is 120 meter cube, there are 400 holes. So, the total production which has come, it is found that the costing is again very less than a rupees also. So, manpower cost is also not very significant in this case. So, we can see except the explosive cost and the detonator cost, other costs are not very significant for drilling and blasting operations. So, you can see these are the capital cost, this is maintenance cost, then it is power cost, it is explosive cost, this is detonator, electronic detonator, and this is manpower, fuel, this is maintenance, this is capital. Again one it is missing, it is around 0.25 paisa for booster. Okay. So, it is closely coming to that 25 or 30 paisa approximately that. So, it is coming to close to 62 rupees. So, overhead cost you can consider 6.2 rupees. So, total cost is coming around 68 rupees, it is coming to this case for blasting with electronic detonator system. So, this is we have seen for the case of for the case of electronic detonator, the costing is coming closely to 68 rupees. Now, if we are considering instead of electronic detonator, we are carrying out it using the Nonel system, that is the surface connection is by TLD, down the hole connection is by DTH, and then for one round of blast, the first TLD is initiated by the electrical detonator that is placed here. So, next onward only the TLD is carrying the connection to the next TLD, only one electric detonator is used for the initiation of the system. So, in this case there is basically we are not considering any change in capital cost and maintenance cost, even fuel cost is not changed, only the detonator cost, explosive cost is also not changed, only the detonator cost will be different. So, we have calculated it. For one hole we need one down the hole nonel and we need one TLD for giving the initiation to the down the hole nonel, and for that the nonel cost is coming that is 100 rupees for the TLD, 240 rupees for the DTH. So, total it is 340 rupees divided by 120 meter cube is the yield from one hole. So, it is coming around 2 rupees 83 paisa. You can recall in our electronic detonator it was coming straightly 10 rupees. So, now it is reduced to 2 rupees 83 paisa, and one electric detonator is used for the initial initiation. So, that is for 400 holes, and that price is I think it is 10 rupees or so, 5 rupees or 10 rupees. If this 5 rupees 10 rupees is there, then its cost is less than 1 paisa itself. Okay. So, this is almost negligible, we can ignore the calculation of this costing. Okay. So, that means there is a significant change in the costing if we are using nonel instead of electronic detonator. So, the total costing is coming, we have changed this 10 rupees to 2.83 rupees. So, overall it is coming around 60 rupees 28 paisa. So, there is a almost savings of 8 rupees if we are using a nonel. But despite of that saving, basically electronic detonator is considered superior over nonel, particularly where the multiple rows are blasts, especially in this case when we are carrying out blasting of 5 rows holes, 80 holes, 5 rows holes, then the accuracy of the delay is very important, so that the burden movement is allowed. Say if nonel etcetera is having the problem of pyrotechnic delay and with the problem of scattering of the delay. So, if the proper burden movement will not be there, then the blasted will be carried out in a choked phase. So, in that case it is very difficult condition. So, suppose we are having a number of holes like this, rows. So, it is expected that when first this hole is blasted. So, when this hole is blasted, we want that our next free phase will be generated like this. After blasting of this next hole, our next free phase will be like this. So, this is our expectations. So, again this will be blasted, no free phase will be generated, and this one will be filled like this. So, this is our expectation, but if the scattering of delay occurs, this will not be the situation. In that case, we may have condition where this first row is blasted and it is generated boulders like this, but instead of second row, maybe third row is blasted ahead of this one. So, this is standing here. Now, this is creating the problem, or maybe a multiple blasting with very proper blasting time is not given. So, what is happening? This is blasted, but the movement of this rock is not properly occurred before that this row is blasted. So, what will happen? Here there may be a little bit gap, like this, and that time this is being blasted. So, the proper blasting will not be achieved. So, that is why this situation must be avoided. So, electronic detonator, in case of multiple row blasting, we must go for the electronic detonator despite it is costing a little bit higher than the Nonel system. So, this we do not want, but Nonel system you can see this is very good in cost wise. Another important part in the Nonel system is that it is not depending on the stray current and lightning etc., but electronic delay is much more susceptible to the stray current, because this is electronic. So, that is why the ampere requirement is less and very susceptible to the stray current. In lightning etc., there is a very high chance that electronic detonator may blast immaturely. Okay. In fact, I think in 2021 in Lakhanpur open cast project, similar incident occurs where in lightning electronic detonators are blasted, premature blasting occurred. So, those things can be avoided by using a Nonel system. Only the problem with the Nonel system is that it is having scattering of delay because of the pyrotechnic nature of the delay. So, this is more or less about the cost comparison part. We hope we can start with the next topic in the next class. Thank you.